the Algebra 1 Summer School, Unit 5, Lesson 2, Mixed Practice. So this is more factoring practice for factoring trinomials and split the middle. All right, there's lots and lots of practice posted on Canvas. There is notes, practice on the notes. There's joke puzzles. There's a little practice called Foolish Factoring, and then there's this practice file. All right, I'm going to do numbers 1, 2, 3, and 4 on this video. If you have questions after I go over questions 1, 2, 3, and 4, make sure you check out the keys that are posted on Canvas, try other problems, or come into office hours and ask your instructor for help. All right, in order to factor this expression, to factor a trinomial, I need to use a method called split the middle. When it's just an x squared, I have to remember that there's an invisible 1 in front of that x squared. So I need to multiply the 1 and the 20 together. 1 times 20 is 20. I need to find two numbers that are going to multiply to 20 and add to this middle number of 12. So two numbers that multiply to 20 and add to 12 are 10 and 2. 10 times 2 is 20. 10 plus 2 is 12. Once I find those values, I'm going to split the middle. Well, when I split the middle, the first term and the last term come down just as they are, as x squared and plus 20. I then end up splitting this 12x with 10 and 2. So I split that up as plus 10x plus 2x. Once I've done that, I now have 4 terms. And I'm going to use a method called grouping to divide these up into 2 pairs of numbers. From each pair, I look for a GCF. The GCF between x squared and 10x is x. So I'm putting x in front and divide each term. X squared divided by x is x. 10x divided by x is 10. Okay. Now, I look for a GCF for the next pair. Because this term is positive, my GCF will be positive. And the GCF between 2 and 20 is 2. I'm going to divide by 20, and divide by 2, and I'm left with x plus 10. Okay. Every time we looked and we made sure that both of the terms in parentheses were exactly the same. That's what we have, which is a really good thing. So I can end up writing my final factored form by taking this x and 2 in one factor and x plus 10 as another factor. And that is the final factored form. All right, same idea here in number 2. I have a 1 that's in front of the x squared. So I have to multiply 1 times negative 12 and find that I need two numbers that are going to multiply to negative 12. They're going to multiply to negative 12, but they have to add, there's a little 1 in front of this x. So multiply to negative 12 and add to 1. All right, well, my options are 3 and negative 4 or 4 and negative 3. So I have to figure out which ones add to positive 1. It turns out that 4 and negative 3 add to positive 1. So that's how I'm going to split the middle. So I'm going to bring down the x squared, bring down the negative 12. I'm going to split the middle up with the 4x and the negative 3x. Once I've done that, now I go ahead and group. First 2 in a group, the second 2 in a group. The GCF between x squared and 4x is just x. And when I divide that away, I'm left with x plus 4. The GCF for the second group has to be negative because that term is negative. And it's going to have a negative 3. When I divide by negative 3, not negative 3x, negative divided by negative here is going to be a positive x. Negative 12 divided by negative 3 is positive 4. That is a good thing for us. Once again, x plus 4 is the same. So I can write my final answer as x minus 3 times x plus 4. Remember, you can check your work by distributing. All right, number 3 and 4. These are a little bit different because this time there's a number in front of everything. So I'm going to start by multiplying 2 times 10. That gives me 20. I need to find two numbers that multiply to 20 and add to 9. That ends up being 5 and 4. 5 times 4 is 20. 5 plus 4 is 9. When I split the middle, the 2x squared comes down. The 10 also comes down. And then I split up the middle with 5 plus 5x plus 4x. Now I'm able to group. The first two terms go in a group. The last two terms go in a group, which allows me to now look for a GCF. Between 2x squared and 5x, they both have an x in common. So I divide by x from both terms, and I'm left with 2x plus 5. When I look between 4 and 10, 4 and 10 have to have a positive GCF here, which ends up being positive 2. I'm going to divide 4x plus 10 each by 2, which gives me 2x plus 5. Again, that's a really good thing to have happen because in my parentheses are both 2x plus 5. That allows me to write my fully factored form now as x plus 2 times 2x plus 5. And there you go. There's your final answer. All right, one more problem here. I always start again by multiplying the 2 and the 15, which gives me 30. I need to find two numbers that multiply to 30 and add to 13. Two numbers that multiply to 30 would be 5 and 6, 10 and 3, 2 and 15. It seems that 10 and 3 multiply to 30, but also add to 13, which is just what we want. So I'm going to go ahead and split the middle here. The 2n squared comes down. Divide this off a little bit. Plus 10n plus 3n plus the last term of 15. Now I can go ahead and group and find some GCFs. Between 2n squared and 10n, it appears that my GCF is going to be 2n. And when I divide the GCF out, I'm left with 1n plus 5. Between the 3n and 15, I'm looking for a positive GCF. And then GCF ends up being positive 3. So I factor out a 3, and I'm left with n plus 5. As always, that's a really, really good thing for us because these two terms are the same. That's your hint that you did things right. So we can get our final factored form to be 2n plus 3 times n plus 5. All right, go ahead and do a little bit more practice on that file. If you have questions, check out the key that's posted on Canvas or come into office hours and ask your instructor for help.